More Earth Science on the way with Norris Teaches Science in another edition of my Earth Science videos, starring me, Mr. Norris. So, in this video, we're going to start talking about meteorology. And today we're going to talk about the atmosphere. And so by the end of this video, you should be able to say, I can describe the composition and structure of the atmosphere. So what is weather? That's what we're going to start talking in here. We're going to talk about meteorology, which involves weather. And weather is the state of the atmosphere at any given time or place. The thing about weather, it is constantly changing. I've been sitting at my desk doing remote learning, teaching really. At this current moment, this is May 2020. If you don't know, that's when we had to do remote teaching for the first time. And I have looked out the window and it has rained, it's windy, but 2 days ago it was sunny and it was in the 80s. But that's how it is. Weather's constantly changing. But what is the atmosphere? It is the gaseous portion of the planet. Um, it is one of the four major spheres of Earth. You had the lithosphere, the geosphere, the atmosphere, the biosphere, and the hydrosphere. So we're just working through the spheres. We're working through all the different things Earth science studies in these videos. But right now we're going to talk about atmosphere and everything about it. And it is the atmosphere is really the planet's envelope of air. And I don't mean just oxygen, I mean all the components of air. And that's where we get in here, the composition of the atmosphere. 78% of the atmosphere is nitrogen, N2, and 21% is oxygen, O2. And so remember that oxygen is what we need to breathe. So only 21% of the atmosphere is what is the oxygen we need to breathe. 1% of the gases in the atmosphere is a whole bunch of other ones, like carbon dioxide and argon and other gases out there. That's 1% of the atmosphere. So the other components are like water vapor, which is H2O in its gas form. It is one of the most important gases for atmospheric processes because it's our source of our clouds and our precipitation. Carbon dioxide is also in the atmosphere. Thing is, it absorbs energy given off by the Earth, and that's good and bad to a point. And then there's another gas called ozone, which is O3, and it's there to absorb harmful ultraviolet or UV radiation from the sun. Now, the layers of the atmosphere. You can the atmosphere is divided into layers, and it's divided into layers based off temperature. What happens to the temperature during that layer? The atmosphere rapidly thins as you travel away from the Earth, so it's thicker down here where we're living versus up where, say, satellites are. Let's talk about each layer. The first layer we're going to talk about is the troposphere, which is the bottom layer. It's the layer that we live in. It's also the layer where all the weather occurs. All the weather that you experience is going to occur in the troposphere. Now, as you go up or increase your altitude in the troposphere, your temperature will decrease. So they do the opposites. As you go up, temperature decreases. Now there is a boundary called the tropopause between the troposphere and this next layer called the stratosphere. And what happens here is as you increase your altitude, temperatures will slowly increase. So their trend is the same. And it's also the location of our ozone layer. We talked a little bit about the ozone layer in astronomy, but remember it absorbs UV radiation so that the harmful stuff doesn't reach us and cause bad events to happen on Earth or to a human. Now, at the top of the stratosphere, there's another boundary layer called the tropopause, and after the tropopause comes the third layer, which is the mesosphere or mesosphere. Just depends on how you want to say it. Up here, temperature decreases with height. So as you go up, temperatures decrease. So they do opposites, and meteors usually burn up in this part of the atmosphere. So So this is where you're going to see, if you see a shooting star, you know it's in that layer of the atmosphere. And then the fourth layer is known as the thermosphere. And as temperature increases with height, so they do this. Their trend is the same. It does thin out into space, but the auroras, like the aurora borealis, where the solar winds are interfering with the magnetic field, you're going to see them in this part of the thermosphere, because there are different parts to the thermosphere, but we're just going to call it all one thing as the thermosphere. So here's a picture of the layer of the atmosphere. You can kind of see the different layers. I'm going to boundary them off. There's one. There's another. There's another. You can't really see that one. Let's get a different color for up here. All right. And then, so troposphere, you can see is not that big, but you can see everything happening. You see the temperature decrease. And then you go into stratosphere, it's kind of constant for a little bit, and this increase. Then you go into mesosphere, it decreases, and then thermosphere, it kind of increases, and then you get to space where it's cold. But another thing about the atmosphere, you have to talk about air pressure. Um, Pressure in the atmosphere will decrease as you go up. So if you increase your altitude, your pressure is going to decrease. So as you get away from Earth, pressure decreases. And air pressure is the force of weight of all the air around. So if you can look at yourself, there's air pressure right now. But this is a little bit about the atmosphere. We're going to talk about all the different stuff that happens inside the atmosphere when we continue talking about meteorology. But I hope you learned something today. And this is Mr. Norris, and he is signing out for this video.